Alright, we're going to continue talking about naming of hydrocarbons. We saw in the previous lectures and in the previous video that chemists use simple naming rules in order to name organic molecules. And you saw the cases of, for instance, simple alkanes, where we take, for instance, this is a 5-membered alkane chain, and you met the concept that the start of the name, pent in this case, tells you the length of the chain, and then the last 3 letters, or last little bit of the name, ane in this case, tells you that this is an alkane. So what we have here is a 5-membered alkane, okay, pentane. Okay, and you also met the idea that we could introduce branching, and we deal with branching by numbering the position on which we put this branched group. So in this case we would have, it's still pentane, but we now have a methyl group, a 1 carbon chain long group on the 3rd carbon, 1, 2, 3, and that means that we name this compound 3-methyl pentane. Okay, so those were the basic things. We just extend this a little, just a tiny little bit, when we're dealing with cyclic hydrocarbons. And what I mean by cyclic hydrocarbons are ones in which the chain isn't just a straight chain, but the chain itself can curve back on itself to make rings. Okay? And here are the first few cyclic hydrocarbons. These are cyclic alkanes, all of them. And we follow the same naming system that we did before. So this one here has 3 carbons in it. You'll remember that we called, for instance, an alkane with 3 carbons in it propane. Well, this is cyclopropane. Okay. This one here on the end here has 6 carbons in it, and this is now cyclohexane. This one down at the bottom has 1, 2, 3, 4, 5, 6, 7, 8 carbons in it, and this is cyclooctane, for instance. Okay, so we're just starting by naming, and we're just saying, well, we'll put cyclo in the front to tell it's a cyclic system. Okay, now we could do, just as we saw branching in, actually let's not do branching, let's look at unsaturation. So just as we saw this, that we could have cyclohexane and cyclohexene, we can have, this is going to require redrawing, sorry. We can now have cyclohexane, cyclohexene, and rather badly drawn because it's difficult to draw these things, cyclohexane. Okay, so we can use exactly the same nomenclature to introduce that we have different levels of unsaturation, whether it be an alkene or an alkyne this time. Okay. These are cyclic systems though, so if you have, for instance, you saw before if you had cyclohexene, if you change the double bond position, you got a different cyclohexene, and we had to tell a number. But if we say change this to double bond over here, that's the same compound, it's just been rotated round. Okay. Okay. The next thing we're going to do is we're going to add a branch to this. Okay, now, whereas before we were starting and we were numbering from the end of the chain so we could get the length of it, now we have a group that is, if we put one group on this, that position is taken to be the first position. It's taken to be the first carbon. Okay, carbon 1. Okay, so this would be, its full name would be 1-methyl cyclohexane. Okay, but often you'll see it written as simply methyl cyclohexane. Okay. If we say, let's make this a bit more complicated. Let's say we have the same cyclohexane ring, but instead we put 2 methyl groups on this. We now have a methyl group in position 1 and a methyl group in position 2. Okay. So that is going to be that's now going to be 1,2-dimethyl cyclohexane. Okay. It's not 1,5-dimethyl cyclohexane. Okay, because as with naming our simple straight chain hydrocarbons, we want to keep the numbers as low as possible. Okay. Now, let's say for instance though, this is an alkene. Okay. Now, alkene is an example of what's called a functional group. It's where a molecule will react most readily. Okay. And it's essentially what gives the molecule a lot of its functionality. So that's why it's called a functional group. Okay. Functional groups are therefore very important. Okay. And when we come to name a compound, we name that importance comes through in the name. Okay. So in this case, we are going to number this, and we've got an alkene here. So the double bond we position at position 1. Okay. Now it's going to be 1, 2, 3. 3. Okay. Again, we're keeping the numbers lowest, so it's position 3. It's not position 1, 2, 3, 4. Okay. Always like that. So this compound is going to be 3-methyl cyclohex 1-ene. Okay. Right. So that's a little bit more complicated than the examples you saw when we were naming simple hydrocarbons. Okay. We're starting to introduce this concept that functional groups, and that functional groups are important. Okay, and we're going to number this as an important group. Imagine we've got, for instance, a very long chain. So this is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a decane chain. And off of this chain, we now put cyclohexane ring. How do we go about naming a compound like this? Okay. Well, we can treat cyclic hydrocarbons in the same way that we treat other side chains. So in this case, we have a chain that is, the longest chain is 10 carbons long. Okay, so the base of the name is going to be decane. Okay, and we're now going to add this cyclohexyl group onto that. Okay, and the cyclohexyl group is on 1, 2, 3, 4, carbon number 4. Okay, so just like we could do with simple chains, we're going to talk. We can call this group at the start of it as 4 cyclohexyl decane. Okay, so that's 4 cyclohexyl decane. Okay. Now, you're probably not going to meet an example that's that complicated, but the naming rules are exactly the same. Okay, let's go the other way around this time. Okay, let's give ourselves a name. So we'll go 1, 2 dimethyl cyclobutene. Okay, and we'll draw this structure out. So we know that it's butene, so it's 4 carbon ring. Okay, so we'll start by drawing a 4 carbon ring, and we've got a double bond in here. Okay, we're not sure the double bond position, so you know and you can assume if you don't say the double bond position is 1. Okay, and we have 2 methyl groups. One is on position 1, okay, and one is on position 2, and that's it. Okay, 1, 2 dimethyl cyclobutene. Okay. Let's do another example or two. Okay, let's do 3 ethyl, 1 propyl cyclooctane. Okay, so this is going to be much more complicated now. Okay, so we have a cyclooctyl ring, so that's 8 carbons now. So let's draw that in. And on carbon number 1, we're going to put a propyl group. Remember, prop means it's got 3 carbons in it, so we're going to put a 3 carbon long chain in here. Okay, 1, 2, 3 carbons. And now we're going to, it's 3 ethyl, so we want it to be 3 carbons long. 1, 2, 3. We're going to put an ethyl group, now that's 2 carbons long this time. We can put the 2 carbons in like that. Okay, so this is 3 ethyl, 1 propyl cyclooctane. I could have quite as easily put the ethyl group on these carbons here, because that would have been the same, just a rotation of the molecule. Okay. Right. Okay. Hopefully you've seen how we name cyclic hydrocarbons. And you see we're building on the rules that we learned when we were naming simple straight chain hydrocarbons. So we follow the same rules about chain length, we follow the same rules about numbering, we follow the same rules about how we change the endings of the names to match the functional group, whether it's an alkane, or an alkyne.